In this video, we will discuss about maximal score after applying k operations. So first, let's understand the question. You are given a zero indexed integer array nums and an integer k. You have a starting score of 0. In one operation, choose an index I such that I is between 0 and nums.length including 0. Increase your score by nums of I and replace nums of I with ceil of nums of I divided by 3. Return the maximum possible score you can attain after applying exactly k operations. So what they are saying is that in the input you are given an integer array and an integer k. You need to perform k operations on this array. In every operation you have to select one element from this array. Let us suppose 3. Then whatever element you have selected, you will maintain a score. You will add this element to your score. So score will become 3. Then you need to replace this element with its ceil of element divided by 3, which in this case will be ceil of 3 by 3. That is ceil of 1, which will be 1. So we need to replace this element 3 with 1 in our array, right? And we need to perform this operation k number of times. In every operation, you will select one number, you will add it to your score, you will apply this formula, and whatever value you will get, you will replace that element with this value in your array. Now at the end, you need to maximize this score, and whatever is the maximum score that you need to return. Okay, so now they are asking us to maximize this score, right? And at every operation, we can choose an element from the array, right? Now, when are you going to get the maximum score? If I say that in each operation, if you always pick up the element which is the current largest or current maximum in your array, right? Because in the array, whenever we are choosing an element, we are directly adding it to the score and we need to maximize this score. So if in each operation you always select the largest element from your array, in every operation you will be adding that maximum element in your score. So your score will be maximized. There are no chances of increasing your score further because we are already choosing the maximum element at each operation, right? So now can I say that in each operation you have to select the maximum element from your array, right? Find out which is the maximum element, take it, add it to the score, apply this formula, whatever is the value you are getting, change that maximum element to this value, then in the next operation again find out which is the largest element and do the same process, right? So now I'm saying in each operation identify the maximum element. Now how are you going to get it? So when, let's suppose in this case your maximum element is 10, right? So you will take 10. When you will apply this formula on 10, what will you get? 10 by 3 is 3 point something and its ceil will be 4. So this 10 will be changed to 4. So what will be your array then? 1, 4, 3, 3, 3. Now which is the maximum element? 4. When you will apply this formula on 4, what will you get? You will get 4 divided by 3, which will be 1 point something and its ceil will be 2. So this 4 will now be replaced with 2. Now if you see here, now the maximum element is not 2. Maximum element is 3 now, right? So that's why I said that in every operation find the current maximum, because in the first operation whichever maximum element you have selected, after dividing it by 3 and doing its ceil, that number will always decrement, right? So it might be possible that now some other number in your array will become the maximum. So that's why in each operation again identify the largest element, right? So how do we identify the largest element in the array? Which data structure can we use for that? Can we use a max heap? What max heap does, it always stores the maximum element at the top, right? So can we say that in my max heap, I will store all the array elements. Then in each operation, I will take the top element, right? Because top element will be the max element. I will pop this out from the max heap. I'll add it to the score. I'll apply this formula and whatever is the value, I'll push it back into my max heap, right? So at the end, when you have applied your k operations, you will get the maximum score and you can return it, right? Simple. Now, but if you closely see, there is a catch here. There is a catch. You can reduce some of your time of calculating the score. So if I say that I have element 1, 2, 3, 4. Now when I will apply this formula on 1, it will be seal of 1 divided by 3, which will be seal of 0 point something, right? So it will give you 1. Then that means when this formula is applied on 1, we get the value as 1. Now when you will apply this formula on 2, then what you will get? Seal of 2 divided by 3, which will be seal of 0 point something, so again 1. So this will also give you 1. So 3 by 3 will be equals to 1 and seal of 1 will be 1 only. So this will also give you 1. Now for 4 it will be seal of 4 divided by 3, which will be seal of 1 point something. So it will give you 2, right? So 4 will change to 2. Now here all these elements 2, 3, 4, and so on, these are changing to some other element, right? Or we can say they are decreasing. But this one is remaining as is. If you will apply this formula on 1, you will get 1 again. If you will again apply this formula on this one, you will again get 1. So it doesn't matter how many times you are applying this formula on 1, you will always get the value as 1, right? Now I am saying that let's suppose the top element in your max heap is 1, or we can say the max element becomes 1 in the array. Now, when your top element will become 1 or when your maximum element will become 1, if either there are only one element in the array, in that case, if it becomes 1, then it will become the maximum element. Otherwise, if all of your array elements are 1, right? In that case, your maximum element will be 1, right? These are the only two cases where your max element will be 1. Now, when the max element is 1, let's suppose your k is 5, and in second operation, your max element became 1. Right. So now what you will do that you will add this one to your score. You will apply this formula and what you will get 1. Then you will again push it into the heap. Right. Then in the third operation, the max element will again be 1. You will add it to your score. You will apply this formula. Again, you will get 1. Again, you will push this in max heap. Then in fourth operation also, in fifth operation also, you will be doing the same thing. Right. So can I say that whenever you are at some operation x, whenever you were at some operation x and your max element became 1, then whatever are the remaining number of operations including this operation, in all of them you will be incrementing your score by 1, right? Because your maximum element will always be 1 in all the remaining operations, right? So, if let's suppose our k was 5 and in the second operation max became 1, then that means in the third operation also max will be 1, fourth operation also max will be 1, and in the fifth operation also max will be 1. So, you are only incrementing your score by 1 in all these operations, right? Now, instead of finding the top element from the max heap again and again for all these operations, can't we just simply add whatever are the remaining number of operations in the score? Because we know that for all those operations, we will be incrementing score by 1 only. So, if we know how many operations are left, we can directly add them to the score and we can return our answer there itself. We do not need to perform the remaining operations, right? And then how you will get the remaining number of scores? So we will be doing when you will apply the operations, we will apply like this, that while k minus minus, then inside that you take the top element, then pop it and so on, right? When you are doing first operation, the value of k will be 4 because you have done k minus minus and initially k was 5. In the second operation, it will be 3. In the third operation, it will be 2. In the fourth operation, it will be 1. And in fifth operation, it will be 0. Right? Now, when you are in second operation, let's suppose, and the maximum element became 1, then at this point, you need to add the number of remaining operations plus this operation. Right? In second operation, the value of k is 3. And how many are the remaining elements? This, and this. So these are total 4. And this is 3. So can I say that the number of remaining operations will be k plus 1, right? So I'll just do that. If my max element becomes 1, then in that case, I will increase the score by k plus 1 and I will return this score. Okay, I hope you got it. So now let's code it out. So first of all, we will create a priority queue because we need to implement a max heap, and max heap is implemented using priority queue. It will take an integer. Let's name it PQ. Now we will create a score variable. We need to return long long. So we will create long score equals to 0. Now we will push all the elements of nums in our priority queue. So we will do for auto num in nums, and in PQ we will push num, right? Then we will apply our operations. So we will do while k minus minus. What you will do? You will take the top element, which will be PQ dot top. Then you will pop it PQ dot pop. Then what you will do? You will check that if the top element is 1, right? In that case, in the score, you will add the remaining number of operations, which is k plus 1, and you will return your score from here itself. And if it is not, then what you will do? In the score, you will add the top element, right? And then you will apply the formula and push it back in PQ. So it will be PQ dot push C of T by 3.0, right? And then at the end, you can return the score. So now let's run this. So our test cases are accepting. Now let's submit this. Now here we are looping n times in our nums vector and k times here. So the complexity will be big O of n plus k. So it got submitted. Thank you so much for watching. Please subscribe our channel.